our house, apparently.
Okay, just like we had a rule for multiplying powers with the same base, that was the add the exponents rule. We've also got a rule for dividing powers with the same base. So what they're talking about is if you have x to the 7th over x to the 4th, how do we handle that since they're not on the same level? Okay. Now if you think about what happens when you move a base, what happens to its exponent, normally we're trying to move them to make the exponents positive when they were negative. But if we move it up and it makes it negative, yes?
So when we move like the negative down and then we can simplify it even farther now?
Yes. Okay, so now I still would say if you've got two bases that are the same on top of a fraction or on the bottom of a fraction, combine those into one first by adding the exponents. We still would do that because you don't want to be moving things from top to bottom and bottom to top and then still have to apply a rule that has to do with division. Okay, but the rule for when they're side by side is we add them. And if you think of what would happen when we move, if we moved this up, it would turn that 4 into a negative 4, right?
Yeah.
And turning it to a negative 4, then adding them would essentially be doing 7 minus 4, not 7 plus. So the rule with division, okay, is top minus bottom as far as the exponents go. So this would be x to the 7 minus 4, which would be x to the 3rd. Now, this should, if you think about what you're actually looking at, x to the 7th means there are 7 of them on top. And x to the 4th means there are 4 of them on the bottom, and every pair cancels out, right? So that means I could cancel out 4 of them with 4 on top, and that would leave me with 3. Okay. Now, if you have more on bottom than there are on top, then it should make sense that your extras, so to speak, would end up on the bottom, right?
Would they be negative then?
On top they would, but we would follow the rules so that we have no negative exponents.
Well, if it was like 4 over 7, then...
Now, if you're following the rule, this would be 4 minus 7. We don't just do what's convenient. Okay, so this would be x to the negative 3, and you still don't want to leave any negative or 0 exponents, so that would be 1 over x to the 3rd. And when you think about it, if there are 4 on top and 7 on the bottom, and 4 of those pairs would cancel out, your extras would be on the bottom, right? Okay. Now, where it gets a little, you have to be comfortable with your positives and negatives, right, Tino? Is if something is already negative, you know, then you have to work with adding or subtracting those. So say I had x to the 8th over x to the negative 2. Okay, it is convenient to just combine those, but we can't just combine them. The rule is top minus bottom, or if you think of it, if you're bringing this one up, that would make it positive, right? So if you follow the rule and do x to the 8th minus negative 2, then you are adding 8 and 2. So that would be x to the 10th.
Goodness, who do you think I am?
Let's do one more basic one.
You just switch them around.
Well, you could, but we want to combine them. We don't want two bases, and switching them means we still have to apply a rule. So what I would do here is it's top minus bottom. So this would be x to the negative 4 minus negative 3.
Which is
This would be plus.
so x negative 1.
So this would be x to the negative 1. And following the rule to get rid of the negative
1 over
would be 1 over x. Okay, so these expressions are just applying a series of rules until you have simplified everything. When you think about it, what we've talked about so far is there cannot be zero exponents. There cannot be negative exponents. And the third one kind of encompasses a lot of things. You don't want to see the same base more than once in your answer. Okay, so if that means you've got two bases side by side that are the same, we add their exponents. We also don't want a power to a power. So you don't want to see two exponents on one base either. Now, you do have to be organized because when we have something like this,
What? Just more down.
okay, when we have something like that, okay, it does start to get more involved because now you have more than one base. Okay, you're not going to be able to combine these all into one because one of your bases is C, one is D. What I would suggest you do is make sure your tops are combined into only one of each. I would do that first, which,
They can't combine into each other.
nope. So if there were a couple C's on top, I would put those into one base first
Oh.
and then worry about the fraction part of it. But we don't have that yet. You will. Okay, but right now I would say, okay, we just need to combine those into one base of C and combine those. You know, worry about your C's first and then worry about your D's. All right, so as far as my C's go, I have C to the negative 1 minus 5.
What do we do? How do you make them both on the top or both on the bottom?
We worry about it when we see if anything's negative. Okay, right now I'm just applying the rule which says I subtract the bottom from the top. Top minus bottom. And then D is going to be 3 minus negative 4. Okay, so this would be
C negative 6.
C to the negative 6. That minus the negative is really plus.
D 7.
D to the 7th. And then this is what you did basically in 8-1. We have one negative exponent we have to take care of, which is that. So what moves?
Goes up.
Yeah, it's a fraction. D to the 7th stays where it is. C to the 6th goes on the bottom. You know, it's the hard part about these is I can't tell you, oh, it takes this many steps. You keep simplifying until you've taken care of all the things that should not be happening. Okay? So let's look at some more.
Good. It's a great song.
All right, see if you can simplify this one.
Working on
Okay, so look at your m's and your n's separately.
That's an
What did you think it was?
So we'd have m,
No.
yeah, -1 minus 3, and
2 minus
n
1.
to the 2 minus 1. So that would be m to the
-4.
-4, n
-1.
-1,
1.
1. So the n stays where it is, and the m moves down, right? So this would be n, and you don't need the 1, over m to the 4th.
Now we're going to do it with numbers.
Well, now we're going to do it with scientific notation.
Ashley! Oh,
And then there's another rule.
we just do that after the test? Yeah.
No.
And just like completely
No.
skip this entire section on the
But then
test.
you will fail the test.
Not if we just completely skip the entire section on the test. We do this and
We need
fail
to
the
make
test.
sure you're fully prepared
For what?
for the test.
What test?
The test.
There's no need for a test here.
I need it.
Bailey,
All right.
Yeah, I do. I need to get my grades up.
Okay, so we said each rule, or most of the rules, bring along with it another application to scientific notation. Okay, and this one is no different. If you're dealing with bases that are similar, we'll say, then really all you should be worried about, because we want our answer in scientific notation, is we're actually going to figure this out, and you'll get a decimal for that, and that's okay. And we're going to apply the rule there. So you are going to do 3.7 divided by 2.814, which is
A number.
1.3. And then we're going to apply the rule to our powers of 10. So this would be times 10 to the 7 minus 8, top minus bottom. So 1.3 times 10 to the -1,
Also, we don't have to change the thing.
negative exponent.
No, we don't have to change, like, because of the decimal, like, if it's not, like, if it was 13, we'd have to, like, add 1, or subtract 1, or whatever, like, to get it.
You would have to adjust it. Scientific notation is what it is. It has to be a number between 1 and 10. And if it's not, we do adjust it.
But we have to adjust it now, though, still, don't we?
No.
Because,
This is between 1 and 10, right?
I know, but we just subtracted from it.
Oh.
We didn't subtract from it. We divided. So this is between 1 and 10. This
Well,
just,
I mean, the 7 and 8.
No, because that's scientific notation.
scientific
It's always-
notation is the number between 1 and 10 times the power of 10.
And that's the power of 10.
This is the power of 10, so
When you put it into regular form.
this has nothing to do with that. This was combining two powers of 10 with the division rule.
But that has something to do with that, right?
Hmm?
But like, if that changes, then we have to change.
This is between 1 and 10. If this weren't between 1 and 10, say this was 13 and not 1.3, then I would have to adjust it. And if I adjust this, then I change that,
I think she doesn't see the period.
not the other way around.
Yeah, but not, okay.
Okay, you can have any exponent you want on that power of 10. As long as this is between 1 and 10, I don't have to make any further adjustments. This is proper scientific notation. Okay, so let's try another one.
True story. Hey, I see.
own calculator. When's your birthday?
December 8th.
When's Chris?
I got the
A
answer.
calculator.
We both asked.
Okay, so if I divide
Yeah.
that, what is 2 divided by 8?
4.
No, not 8 divided by 2, 2 divided by 8.
Oh,
0.25
I was looking at the decimal.
times, now it's 10 to the third, you're going to subtract 8. You can do it right there if you want, okay? So that would be 10 to the negative 5, right? Now, this is a case where this is not between 1 and 10. We are going to adjust this. It's going to move 1 to the right,
Plus
So
that.
we subtract.
so we subtract. So this would be 2.5 times 10 to the negative 6.
We'll get to use calculators, right?
Mm-hmm. Yeah.
Because I'm not good at, like, I thought it was -4.
When you have two negatives that you're combining, you actually add them. Same sign, you add. Different signs, you do take the difference, but you keep the sign of the larger, so to speak, number.